Continuing our discussion on ADA, and in here we're talking about the stairs. The last example that I used was 14 foot high, floor to floor. By the way, this is the abbreviation you see on architectural drawings, FLR for floor. And maximum riser height per code is maximum 7 inches. And then the formula where 14 feet was multiplied by 12 divided by 7 inches, and that gives you 24 risers. Now, what happens if your floor to floor height is 13 feet? And this happens quite often. Because the more height, the more cost for projects. So with the 13 feet high, a lot of office buildings have a 13 feet floor to floor height. Because if this is your floor, and this is the other floor, and this is floor to floor height, again the symbol for the height, so from here to here, that's 13 feet. Then you need a 9 feet clear ceiling height. So that is the ceiling. And then the remaining part would be for your structure, mechanical equipment, ductwork, lighting, etc. That's a very comfortable dimension to work with. So what if the floor to floor height is 13 feet? So here is the formula. Remember the formula from the lecture 3. The formula was floor to floor height in feet multiplied by 12 divided by 7, which is the maximum riser height. So if I just use the calculator, in this case I have 13 multiplied by 12 divided by 7. That gives me 22.28. So you can see the result is fractional. And this is, so if I go back to here, so what we did was 13 feet multiplied by 12 divided by 7, just to make sure we continue, you can continue this well. 22.28 riser. Now, I put exclamation mark because you cannot have a 0.28 riser. All risers are to be equal. When you are more than 22, that means you cannot go back to 22 because simply your number will increase in the riser height. This is the number you got. So you always round up to the next complete non-fractional number. So in this case, the roundup for 22.28 will be 23, and that would be the actual number of risers that you're going to use for the set of stairs. Now, if someone asks you if using 23 risers, what is the height of each riser? So height of each riser is determined by total height floor to floor in feet multiplied by 12 divided by the number of risers. So in this case, total height was 13 feet multiplied by 12, and this number was selected as 23. So let's see what we get using the calculator. 13 by 12 divided by 23. That gives you 6.78 inches. That is the exact height of riser that must, you see I put the word must underlined, be noted on plans. So the stair is constructed correctly. Now 6.78 is still larger than 7. I'm sorry, that was not a right thing. Sometimes happens. So 6.78 is still smaller than 7 inch. So as long as your maximum is 7, you are at 6.78, so you are okay. And that is the way you calculate your stairs. Couple of additional information on the stair. The handrail on the stair is, if this is your riser, the handrail as it goes up is measured. This is called nose of thread. If you get a vertical line coming up from here to here, that height is established best dimension 34 inches. When it comes to, when the stair, let's say you have a stair here, here's the floor below, here's the floor above. Here is the handrail, and the handrail height is at 34 inch. From the nose of the thread, if you bring a vertical line, when the handrail comes into here, it has to turn for the distance of 12 inch at top of a stair. At the bottom, when you get to the last riser, this handrail has to continue for the dimension of your thread, and once it gets to the thread, it has to extend out for 12 inches. This is an ADA rule that applies to all stairs. So therefore, if all of your publicly used stairs have to follow this rule. You have a 12-inch extension, as it calls it, to the handrail, 12 inch at the top, and at the bottom, the handrail, when it hits the nose of the thread at the last riser, it has to continue in the same direction on the thread for the length of the thread, which is about 11 inches, minimum 11, and then extend out parallel 12 inches. So at the bottom, you will have 23 inches of extension, and on the top you will have the 12 inch of extension. On your textbook, I would like you to continue looking at, first of all, read the chapter 11, specifically as you're going into it, you should look at the dimensions, the symbol for ADA, which is noted on page 202, maneuverability of the person on a wheelchair shown on page 203, accessible route on 204, the meaning of it. Then if you move to page 206, this still deals with the accessibility issues, routes, aisles, how you can get from one point to another on page 207, and 208 on page 209 shows you the arrangement of the stalls, the vans. One is, especially on the diagram on the top on page 209, it shows a van condition, which is 8 foot you have to have for an accessible van, and then a 5 feet for the regular car. And then at the bottom it shows for the number of the stalls and how you will get it arranged. Then, for example, I would like you to take you to page 214. When you are in a theater or any other space, you will see that the top row is allocated for the person with disability because the change of level simply is impossible to accommodate in a step-down amphitheater condition. So the top row belongs to the ADA. I will talk more about the information that is noted on the restrooms, which starts on page 215 and 219, etc. There is a lot to cover in this area, and we will continue with the lectures. But first, this is the first group of lectures for Module 5, and it follows by some assignments, and then I will add additional lectures to this module.